display is exactly the same as we left it in the frequency table histogram video. Here is the random data we generated. Here is the frequency table we built from this data. This is the frequency distribution chart that depicts the data on the frequency table. This is the cumulative distribution chart, also built from the frequency table. The frequency distribution chart is often called the histogram and is how we will refer to it from now on. The class boundaries are the values shown on the horizontal axis. The low and high class boundaries correspond to the left and the right side of a given rectangle. The frequency is plotted on the vertical scale, which means the height of a given rectangle represents the frequency of the corresponding class. For example, the frequency of the first class is 23, which is the height of the first rectangle. The left side of the rectangle is located at 0.5, which is the low boundary of the first class, and the right side of the rectangle is located at 5.5, which is the high boundary of the first class. Let's look at another example. The height of the ninth rectangle is 15, which corresponds to the frequency of the ninth class. The location of the left and the right sides of the rectangle correspond to the low and the high boundaries of the ninth class. Let's now turn our attention to the cumulative distribution. The frequency and the cumulative frequency have the same class boundaries. The cumulative frequency is a running total of the frequency. That is, the cumulative frequency is the total of the frequencies up to and including the current class. For example, the value of the cumulative frequency is 23 for the first class and is the level of the first class. The class boundaries of the first class are 0.5 and 5.5. The cumulative frequency of the second class is 42, and its boundaries are 5.5 and 10.5. Note that 42 is the sum of the frequencies of the first two classes. We should also note that the sum of all the frequencies is the total number of values in the dataset, which is 225. The value of the cumulative frequency's third class is 70, which is the total of the first three frequencies. Because the cumulative frequency is a running total of the frequencies, the cumulative distribution always increases from left to right. The maximum value of the cumulative distribution is 225, the total of all the frequencies of all the classes. We discussed how to calculate the relative frequency in the frequency table histogram video. Please watch it again if you need to review. The important property of the relative frequency is that it is the probability of a value, randomly selected from the dataset, falling between the low and the high class boundary. For example, if we were to randomly select a value from the dataset, the probability of it falling between the values of 0.5 and 5.5 is 0.102, or 10.2%. If we let x represent the random variable, that is, the value we randomly select from the dataset, the probability can be expressed by the following equation. The equation is read as follows: probability of x being greater than 0.5 and less than 5.5 is 0.102. Let's determine the probability of a value being in the 8th class, which would be the probability of x being greater than 35.5 and less than 40.5 is 0.076. In general, the relative frequency of a class is the probability of a randomly selected value being between the low and high boundary of the respective class. Let's now discuss the histogram. To review, the height of the rectangle depicts the frequency of the corresponding class. Since each of the frequencies is divided by 225, the sum of all the frequencies, to get the relative frequency, the rectangles will have the same relative height when plotted against the relative frequency, as we will see using the axis on the right. The frequency of the first class is 23, but the relative frequency is 0.102, as plotted here. Another example, the frequency on the 8th class is 17, and the relative frequency is 0.076, which is plotted here. Each of the rectangles can represent either the frequency or the relative frequency, which we now know is probability. Let's now turn our attention to the area of the rectangles. Recall, the area of a rectangle is the product of its height and width. We will use the relative frequency as the height of each rectangle. The width will be considered to be 1, since each rectangle is 1 class width wide. If we multiply the relative frequency by 1, we will have the area of the corresponding rectangle. But remember, any number multiplied by 1 is the original number. For example, the area of the first class is 0.102 times 1 equals 0.102. Therefore, the area of the first rectangle is 0.102 and is the same value as the relative frequency. The relative frequency is the probability of the corresponding class. It then follows that the area of each rectangle is proportional to the probability of the corresponding class, and the probability of each class is the relative frequency. The equivalence of the area of the rectangles and the probability of the class it represents is an important concept and will be used throughout these videos.